In this video, we'll be working with reciprocal of linear functions, and it's a very good idea to start with reciprocal of linear functions because if you're able to graph f of x equals 1 over x, then you don't really need any grade 12 knowledge to graph the reciprocal of any linear function because you can just graph it through transformations. If you take a look at our first example, f of x equals 1 over x minus 1, you can really graph it by taking 1 over x and shifting it 1 unit to the right. So have the graph of 1 over x in your head and shift it 1 unit to the right. So for any rational function, which is the reciprocal of a linear function, before you even use any grade 12 technique, you should rely on what you learned from grade 11 about transformations and generate a quick sketch in your head of that function, and then start working with your new techniques. It will really help because if you have the correct graph of the function in your head, it really helps when you try to answer these questions. Okay, but in advanced functions, we're going to approach it a little differently. Okay, we're going to break it apart and find the asymptotes, and we're going to look at how this function behaves. So instead of transformations, we're going to take a different approach to it. But you know what, like I said, don't forget about transformations because you can give yourself the graph and you know the answer in advance. And in fact, at the end of this lesson, I'll give you a third way to graph 1 over x minus 1. Okay, so, but this is the way that I want you to focus on for this unit. Okay, we're going to figure out the properties for this graph, and then we're going to piece it together and draw the graph of the function. Okay, so state the equation of the vertical asymptote. Alright, so from what we did in the last lesson, we said that we can determine the equation of the vertical asymptote by looking at the denominator, okay? By finding the zeros of the denominator, you can find the equation of the vertical asymptote. So what is a 0? 1, okay? Because 1 will make x minus 1 0. So the equation of vertical asymptote is x equals 1. And if that's the only vertical asymptote, then guess what? Your domain, all values of x except for 1. Okay, now one thing you should know about vertical asymptotes is that you can approach these asymptotes from the left-hand side and from the right-hand side. Okay, and one of two things can happen. Okay, when you approach a vertical asymptote from the left or from the right, one of two things can happen. It can either shoot up towards positive infinity, or it can shoot down to negative infinity. Okay, so we can do this algebraically, or we can use a table to help us demonstrate the behavior near the vertical asymptote. So in this case, I used a table here. So remember, we're going to approach the value of 1 from the left side and from the right side. But you need two tables because one's for the left and one for the right. So the first table here is 1 from the left. So this superscript of a subtraction or minus here, that means it's slightly less than 1. If it's slightly less than 1, it means you're approaching 1 from the left. Okay, and here the superscript of a plus here, that means it's slightly greater than 1, so I'm approaching 1 from the right hand side. Okay, it makes sense. If I'm greater than 1, I'm approaching from the right hand side. All right, so I'm going to sub in these values. So 0, so negative 1, half of 0, 1/2 would be, let's see, 1/2 negative 2, and 0.9 negative 10, 0.99 is negative 100. Okay, you can keep getting closer and closer and closer ones, 0.999, 0.99999, and so forth and so on. So hopefully you can see as you approach 1 from the left side, and you can get ever so close, okay? And that's a very hard word to define in math, close, but hopefully you see a pattern. As you approach 1 from the left, the pattern says that the function will go towards negative infinity. Remember, there are two options. You either go towards positive infinity or negative infinity. In this case, it's negative infinity. Okay, Now let's find the behavior from the other side of the vertical asymptote. So 2, if I 7, 2, f of 2 is 1, f of 1.5 is 2, and 10, and 100. Ooh, so if I approach 1 from the right hand side, the table is telling us that the function is going to approach towards positive infinity. Okay, positive infinity. Beautiful. And if you go back up to the top, it makes sense what we wrote for the behavior near the vertical asymptote. Okay, so let's quickly look and try to study it algebraically here. If I approach 1 from the left, that means that the denominator will give me a very, very small negative number. And 1 divided by a very small negative number will be a very large negative number. Okay, whereas if I approach 1 from the right, the denominator will be a very, very small positive number. Okay, a very small positive number in the denominator means that 1 over that very small positive number will be a very large number. So what we wrote here, it makes perfect sense if you study f of x. Okay, so for the end behavior, we can actually do what we did for part C. You can build a table. Okay, so you can do something like this. You can do, I don't know, like 100, 1,000, 10,000, and then study f of x. Okay, so this will be this will tell me the behavior of the function as x approaches infinity. So by filling in this table, you can, as x approaches infinity, f of x approaches, okay, whatever the pattern tells us. And you can do another table for the negative values because you want to go towards negative infinity. But you know what? I'll create the two tables, but I'm not going to fill them in, okay? Because I actually want a different way to figure out the end behavior, okay? So you can fill in the table if you want, but what I'm going to do is determine the end behavior by just studying the function. Okay, so let's take a look. If I sub in a very large positive value for x, okay, just use your imagination, a billion, a trillion, a quadrillion, I don't know, whatever you want, okay, subtracted by 1, guess what? It's still a very large positive value. And then 1 over that very large positive value will be a very, very small positive value. In fact, it's so small, it's very, very close to 0. You'll get closer and closer to 0 as the denominator gets larger and larger and larger. Okay, as x becomes larger, the denominator becomes a larger and larger positive value. So hopefully, with all that said, your function will approach 0. Okay, because your denominator is growing. Okay, and it's going to approach 0 from above. Okay, and it'll make more sense when I write down, or when I draw the graph, but it's going to approach 0 from above, meaning it's like 0 0.1, 0 0.9, 0 0.8, 0 0.7. It's getting closer and closer, but the values will still be slightly positive. Okay, and if you're filling this table, and if you study the function, you'll get the same result. If the denominator becomes a larger and larger negative value, the function will once again approach 0, but it'll be approaching 0 from below, because it's going to become a smaller and smaller and smaller negative value. Okay, I'm very tempted to fill in these tables for you, but you know what? If you fill them in yourself, I promise you'll get the same pattern. Okay. Okay, so all this work, I really want to just sketch the graph. Okay, so first thing I'm going to sketch the vertical asymptote. I forgot to mention. So as x approaches infinity, f of x approaches 0 from above. As x approaches negative infinity, f of x approaches 0 from below. So both these statements basically tell me that there's a horizontal asymptote. Oh, I forgot. State the equation of horizontal asymptote. It's approaching 0, approaching 0. Whether it's above or below doesn't matter. The fact remains the horizontal asymptote is y equals 0. Okay? So let's sketch in our asymptote. So for all rational functions, you'll see that I always sketch in the asymptotes because that basically gives me it gives me the basis of the graph. Okay, the rest of the graph will be dictated by where my asymptotes are. So it gives me a good foundation of where to start. Okay, so there's actually one point I really want, which is the y-intercept. So I'm looking really quickly. To find the y-intercept, I find f of 0. F of 0 is -1. Okay, 1 over -1 is -1. So I'll plot that y-intercept very quickly. Bam. Okay, I'm going to cheat a little because I know I remember something from grade 11. The 1 over x function, it has odd symmetry. Okay. Oh, sorry, it has point symmetry about the origin. So it's an odd function. So this one's not an odd function, but it still has point symmetry about this point 1, 0. Okay. You know what? I think I'm ready. So it's approaching. As x approaches -infinity, f of x approaches 0 from below. See, that's why it makes sense. 0 from below, right? This is 0, 0 from below. And then, as I approach this vertical asymptote from the left-hand side, if you look up top, left-hand side, what did it say? -infinity. Beautiful. Yes. And the right-hand side is positive infinity. And the end behavior, as x approaches infinity, f of x approaches 0 from above. Beautiful. All right. Not very pretty. You know what? It's supposed to look, like I said, it's supposed to have point symmetry about this point, but you know what? I'll live with that. I'll live with that. Okay. So, strangely enough, they ask us for the domain again. I did the domain, but oh, whatever. I'll give it again. So, domain, x cannot be 1. Now, what about the range? Y cannot be 0. This graph has no x-intercept, so it makes sense that we have this restriction of y cannot be 0. But y can be anything else, though. Okay, lastly, they want us to use the graph and state the intervals when the function is increasing and when is it decreasing. So, increasing. So, increasing means that as you go from left to right, you're going up. Okay, so let's see. If I am on this graph going left, right, down, 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 down. Okay, so on this branch, we're not increasing. How about on this branch? Down, 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 down. So if you study this function, it is never, this is null. Null means never. So it's a null event, which means it never it never increases. Okay, so if you study this graph, it's never increasing. It's always decreasing, in fact. So this first branch is decreasing, 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 decreasing. All right. So it's decreasing from -infinity to 1, and 1 to infinity. Okay, we cannot include at 1 because at 1 it's undefined. There's a break in the graph, so we can't say at 1 whether it's increasing or decreasing. Nothing's happening there. Okay, well, something's happening, but it's a vertical asymptote. Okay, all right. So that basically covers the big ideas of what we're going to do in this unit. Okay, we're going to find the vertical asymptote. We're going to find the horizontal asymptotes. And then we're going to find the y-intercept, and we're going to piece together the graph. Okay? And once you have the vertical asymptote and the end behavior, once you have the vertical asymptote and the horizontal asymptote, you should be able to find the end behavior and the behavior near the vertical asymptote. Okay? So, f of x equals -2 over x plus 4. Alright, so to be honest with you, like I said in the beginning, you can graph this function based on your knowledge of transformations applied to 1 over x. So I won't go over them again, but you should be able to do that. So I personally have an idea of how this graph already looks like. But I'm going to still fill in this whole table. Okay, and x-intercept. X-intercept, none. How do I know it's none? Well, how do you find x-intercept? So x-intercept, let f of x equal 0, right? That's what you learn in grade 9, let y equal 0. If I let y equal 0, or let f of x equal 0, you get this beautiful equation here. And if you try to solve for x, you get 0 equals negative 2. What? Which means this is an inconsistent equation. Therefore, no x-intercept. Okay? Now, y-intercept. Oh, there's definitely a y-intercept. Y-intercept is f of 0, right? So for x-intercept, you let y equal 0. For x-intercept, you let... For x-intercept, you let y equal 0. For y-intercept, you let x equal 0. So you know what? Just so you don't get confused, I'll show you my work. F of 0 is negative 2 over 0 plus 4, which is negative half. Bam. Okay. Let's keep going. Vertical asymptote. So you look at the zeros of the denominator, which is negative 4, so x equals negative 4. Okay. As x approaches negative 4 from the right, what's happening to my function? And as x approaches negative 4 from the left, what's happening to my function? Remember, one of two things is happening. It's either going towards positive infinity or negative infinity. Okay. Now, what about end behavior? As x approaches infinity, what's happening to my function? As x approaches negative infinity. So one is to the far right and one is to the far left. Okay. And you must be wondering, why am I not filling it in? Because I have a secret shortcut here. I have a secret shortcut. I'm very reluctant to share it, but I'll share it. Okay. All right. So horizontal asymptote. You know what? If I knew these values here, I would know the horizontal asymptote. So one thing I should mention here is that if I have a reciprocal of a linear function, the horizontal asymptote will always be y equals 0. Okay, so let's use our imagination. Why is it that the horizontal asymptote is always y equals 0? Because think about it. When I approach infinity or negative, as x approaches infinity or negative infinity, the denominator is significantly larger than the numerator. The numerator is just a constant, whereas the denominator is growing and growing and growing and growing. Whether it's going to be a big positive number, a big negative number, it doesn't matter. The ratio, the quotient will approach 0. Okay, negative 2 divided by whatever it is, it's going to approach 0 as x becomes larger and larger and larger in magnitude. Okay, so that's why when I'm working with a reciprocal linear function, the horizontal asymptote is always y equals 0. Okay, so in fact, I'm going to write this down. 0 and 0. All right. So what I don't know is it 0 from above or 0 from below. But like I said, I'm gonna cheat a little. I'm gonna use my graph. Okay. And domain and range. You know what? I'm gonna use my graph as well. So let's do it. All right. Let's sketch on our asymptotes first. Give us a good guideline here. And what was it? Negative 4. So I'll do 1 here. 1, 2, 3, 4. Alright, and the y-intercept was negative half. So right here. Bam. Okay. Alright, let's see. Anything else we have here? Nope. Okay. So I always ask my students that let's look at this vertical asymptote here. We have a vertical asymptote of x equals negative 4. Okay, and what I'm going to do is I'm going to work with the right side, the right-hand side of this vertical asymptote. One of two things can happen as I approach from the right-hand side. I can approach from positive infinity, or I can shoot up to positive infinity as I approach this vertical asymptote from the right-hand side, or I can shoot down towards negative infinity. Only one of these are correct, okay? We can't have both of them. So the question is, which one should we choose, okay? So we can actually avoid doing the table that we did on the first page. You don't need the table. Okay? So when I ask my students, half of them say positive, half of them say negative. But hopefully, if I give you 10 minutes to think about this question, I'm really hoping if you investigate, it makes no sense that it's positive. It can't be positive infinity, right? Why can't it be positive infinity? Because, I'll sketch it back in. Because this is going to happen. And why can't that be correct? It's very faint because I don't want to mess up my graph. It can't happen because you're introducing an x-intercept. But you just said earlier, or we just said earlier, that there are no x-intercepts. So because there are no x-intercepts, the graph must do this. And it must approach 0. And don't introduce an x-intercept. Bam! Beautiful. Okay? I'm trying to make this symmetrical, or with the point symmetry about this point here, but you know what? I really want to highlight the behavior near the vertical asymptote and the end behavior. Okay. Now, students also ask me, well, Mr. Lamb, how do you know that on the left side of this vertical asymptote we're approaching positive infinity? So here's my other shortcut that I'm gonna spoil. Okay, so I'll prove to you why this is the case later on, but this factor x plus 4, I'll write it like this, but you could see it as this. It's x plus 4 to the power of 1. The factor is raised to the power of 1, and if the exponent is odd, that means that the behavior on the left side and the right side will be opposites. So one will be negative infinity and one will be positive infinity. And since I knew that this is a negative infinity, then that must mean this is positive infinity. Now, if the exponent was even, like 2, 4, 6, 8, 10, then on both sides of the vertical asymptote will have the same behavior. Both will be pointing down to negative infinity, or both will be pointing up to positive infinity. Okay, but like I said, this case the exponent was odd, so that's why the behavior is opposite. One is positive and one is negative. But yeah, there's your graph. Okay, so once I have this graph, guess what? Ooh, beautiful. This, I don't have to do all that table. I can ignore it right away. So if I approach negative 4 from the right hand side, it's negative infinity, positive infinity, and from the graph, 0 from below, 0 from above. By the way, this I could have just looked at the equation and figured this out. Okay, domain, range, all of this, I'm going to look at the graph. Domain, I didn't need the graph. X is not negative 4. Range, y is not 0, no x-intercepts, makes sense. Intervals of increase. So this one, it's always increasing basically. Right? The first branch is increasing, and then the second branch, it's increasing. Which means it's not decreasing. Where is the function positive? It's positive on the first branch, and it's negative on the second branch. Beautiful. So there's my little shortcut. So if they ask me questions to fill in this table, like I wouldn't show that giant table I had in the first page. I can reverse engineer this this solution, because I'm gonna get the graph first and then fill in this information, as opposed to get this information and then fill in and then use that to draw the graph. It's much easier to just get the graph very quickly. So believe it or not, if you give me the reciprocal linear function, I can actually graph it very, very quickly. Not only because of what I understand from transformations from grade 11, but it's because all I need are the intercepts and the asymptotes, and then it pieces together itself. It's like a puzzle. There's only really one thing that fits the provided information. Okay. All right. So you know what? I'll show you one more. So let's see. Let's do something interesting. Let's do negative 3x minus 4. Okay, so this one So the vertical asymptote is 4/3, x equals 4/3. This is not drawn to scale, so please excuse the scale. The horizontal asymptote is y equals 0. The y-intercept is 3/4. Okay, so I did that. You can double check the math, but it's correct. Okay, so remember, you can't introduce new x-intercepts, so it has to do this. It has to shoot toward positive infinity from the right side, which means from the left side it's going to be negative infinity. Approach 0, bam, bam, bam. Okay, so you see how I did that so quickly? So from here, from this equation, I can generate the graph very quickly, and then from the graph, I can fill in all this information. Okay, it's much easier that way, as opposed to working out all this information. Now, if it was a standalone question, for example, if they just give me the function and then ask me, hey, what's the behavior near the vertical asymptote? Then sure, I'll just make the table and fill in the table and show them. Okay. I did want to mention one more way of graphing reciprocal linear, but I'll save it for the next lesson when we talk about reciprocal quadratics.